Okay, we're asked to evaluate this indefinite integral. And when things get complicated, you want to try using integration by parts. And it's kind of like where you make two substitutions. You start off integration by parts by choosing a u and choosing a dv. You've got to substitute everything here. Okay. And so the trick to it is to pick a u so that if you were to keep taking derivatives of u, it would turn into nothing. Okay. So we'll let u be x squared, because I know the derivative would be 2x, and then if I took another derivative, that would be just 2. And then if you want to keep going, you take a derivative, that'd be 0, right? So that would eventually turn to nothing. That helps break it down. And then for dv, we have to substitute everything, so dv has to be sine of x. That's the first part of integration by parts. Okay, the second part is where you would you need to also figure out what du and what v are based on your choices, because those are parts of the formula. So du would be the derivative of u with respect to x, so that's just 2x. And then v would be the antiderivative of sine of x. And so that's negative cosine of x? Yeah, because the derivative of cosine is negative sine. So the derivative of negative cosine would be positive sine. So we've got our antiderivative of dv. So now that we have all four of those items, now we can plug them into the right side of the integration formula. uv, so u is x squared. V is negative cosine of x. I'm just going to put the negative sign out front. And we need to subtract that by the integral of v, which is negative cosine of x. So look, there's going to be a negative cosine here. It's a negative minus a negative, so that's a positive. So I took care of the negative sign in that cosine of x. And then du is 2x. So you could put 2x over here, but the convention really is to factor out that 2 because it's the integral operator is a linear operator. Okay, and so it's simpler. Instead of having x squared, now we have x, but this is another expression that would need the integration by parts formula to find the antiderivative. So we're starting over with this simpler version. So integration by parts helps us break it down. We'll let u be x, means dv needs to be cosine of x. So that means v is the antiderivative of cosine of x, so that should be sine of x. And then du should be 1, because that's the derivative of x. Okay, so we've got a 2 on the outside, so I'm going to put a parentheses, and then we're going to use the integration by parts formula. It's uv, so it's x sine of x minus the integral of v, and then du is just 1. So we'll put a dx at the end, because it's with respect to x there. So we use the integration by parts formula twice in this problem. And make sure you watch your parentheses. If you factor out a 2, that 2 needs to eventually multiply to everything inside. Now we can evaluate that last integral without having to use the cumbersome integration by parts. Antiderivative of sine is negative cosine. That's because the derivative of cosine would be negative sine. So look, that's a minus a negative cosine of x. Oh, and I've been forgetting my constant c's. We'll just put that at the end because 2 times a constant c is just some arbitrary constant c. Okay, and now all that's left is cleaning it up, and then we're done with our antiderivative. You could check it by taking a derivative with respect to x, and you should see it turns out to be the same thing as what we started with. Okay, so that 2 distributes to everything. And then that's minus negative cosine of x, so that's plus 2 cosine of x. And I don't think there's any like terms that we can combine, so that should be our antiderivative.